There's something all around us, an invisible substance that has completely infiltrated our planet. It's been found in the deepest parts of the ocean, it's floating in the air we're breathing right now, and maybe most disturbing of all, it's already inside of us. This is the story of microplastics, a problem that we created and one that is now coming back to us in ways we're only just starting to understand.
So let's just cut to the chase with a pretty blunt question. Are we quite literally eating our own trash? The answer is way more complicated and honestly more concerning than you probably think. Let's dive into the research and see what it tells us.
Okay, so to even begin to answer that question, we first need to get a handle on the culprit. What in the world are these invisible invaders we call microplastics, and how did they manage to get, well, everywhere?
So what are we talking about, size-wise? The official definition is any piece of plastic smaller than 5 millimeters. To give you a mental picture, the biggest ones are about the size of a sesame seed. But, and this is key, they get way, way smaller. So small you need a microscope to even see them.
So where do all these little things come from? Well, the sources show they really fall into two main buckets. First, you have your primary microplastics. These are actually made to be tiny right from the start. Think of those little microbeads that used to be in things like face wash. But the much, much bigger source is secondary microplastics. And these are the tiny fragments that come from larger plastic stuff, bottles, bags, fishing gear, breaking down over years and years out in the sun and the waves.
Now this is where it gets really eye-opening. How do these particles get into the ocean? I mean, mismanaged waste, sure, that's a big one. But look at some of these others. Tire wear. Every time a car drives, tiny bits of the tires wear off, and that dust gets washed into our rivers. Or synthetic fibers. Every single time we do a load of laundry with clothes made from things like polyester or nylon, thousands of tiny fibers go right down the drain. It's just so deeply woven into our modern lives.
And the end result of all this? It's a truly global contamination. The research is crystal clear on this. Microplastics are everywhere. They're not just near big cities. They've been found in the most remote places on Earth, from the ice in the Arctic all the way down to the deep sea floor. There's really no part of the ocean that's been left untouched.
All right, so we've established this stuff is everywhere. The big question is, so what? What harm is it actually doing? Let's start in the ocean, because that's where the evidence of the damage is it's undeniable and, frankly, tragically well documented.
And when we say it affects marine life, we mean all of it. The impact starts at the absolute bottom of the food chain, and it works its way all the way to the top. From the tiniest little plankton mistaking a piece of plastic for food, all the way up to huge animals like sea turtles and seabirds. Basically, if it lives in the ocean, it's at risk of eating plastic.
And look, this isn't just a theory. As this chart shows so clearly, studies have documented some really severe, direct biological harm. Animals that eat microplastics, they don't grow as well, they have a harder time reproducing, and in a lot of cases, it leads directly to higher death rates. The damage is real, and it is measurable.
Yeah, this quote from the research really just sums it all up perfectly. Imagine an animal eats a piece of plastic. Its stomach feels full, so it stops eating, but it's getting zero nutrition. That can lead to starvation, it can cause internal injuries, and it can even change the way the animal behaves, making it an easier target for predators.
But the physical damage, believe it or not, is only half the problem. Scientists have this incredible term for what's happening next. They call it the toxic taxi effect. I want you to think of a single plastic particle as a tiny vehicle, and on its journey through the ocean, it's picking up some really nasty passengers.
So who are these toxic hitchhikers? Well, first you've got the chemical additives that were put into the plastic when it was made, things like flame retardants or plasticizers. Second, these little particles act like tiny sponges, soaking up other dangerous pollutants that are already in the seawater. And third, their surfaces are the perfect real estate for harmful bacteria and other microbes to grow on. So when an animal eats just one tiny piece of plastic, it's not just eating plastic, it's getting a concentrated dose of all these other toxins delivered right into its system.
And this is the moment where the story really comes home. We've seen the absolute chaos this is causing in marine ecosystems. But since we are all part of one big global ecosystem, the next question is unavoidable. What about us?
Right. We know it's moving up the marine food web. It's in the fish that other fish eat. So what happens when that food web ends up on our dinner plate? Is this just an ocean problem, or is it a human problem too?
The research points to three main highways for these plastics to get into our bodies. The most obvious one is eating contaminated seafood, especially things like clams and mussels that filter water.
But it doesn't stop there. It's also been found in our drinking water and even in table salt. And maybe the one that surprises people the most is that we can actually breathe it in. Tiny plastic fibers are floating in the air all around us.
And so we get to the crucial point. This is not a what-if scenario anymore. The evidence is now in. Scientists have detected microplastics in human blood, deep inside our lungs, and even in placentas, which means they can potentially pass from a mother to her unborn child. They have gotten past our body's most secure defenses.
So we know they're in us, but what does that actually mean for our health? This is where the science gets a little more complex, so it's important to be really clear. Let's do a direct comparison, what we know for sure about marine life versus what we're starting to learn about human health.
And this right here lays out the critical difference. For marine animals, the science is pretty much settled. The harm is direct, it is severe, and it is widely documented. For humans, it's a different story. The risk is what scientists call emerging. We know the particles are there, but figuring out exactly what they're doing to us is now one of the biggest priorities in medical research.
Let's just walk through this table for a second, because it's really important. Over on the left, for marine life, you see these massive system-wide impacts. Food webs are being destroyed, biodiversity is being lost. The effects are catastrophic. Now look at the right side, for humans. The known effects so far are things like inflammation and stress seen in lab settings. There is a very strong suspicion that they could be contributing to chronic diseases, but that link just hasn't been proven or quantified yet. We know the what, they're in us, but we don't yet know the full so what.
So, given this clear and present danger to our oceans and this emerging, really worrying risk to ourselves, the final question has to be one of action. How do we even begin to turn this plastic tide?
Well, the solutions have to be just as big and interconnected as the problem is. The research points to a strategy that attacks this on multiple fronts. First and foremost, we have to tackle this at the source by reducing how much plastic we produce in the first place. Second, we need much better systems to catch these particles before they escape, like advanced water treatment. Third, we need regulations on specific sources like textiles and tire manufacturing. And finally, we have to pour resources into research to fully understand the long-term risks to human health.
And that really brings us to the final thought here. The devastation that we are seeing in our oceans, it's a warning shot. It's a crystal clear signal of what happens when a man-made material completely overwhelms a natural system. And now, that same material is inside our own bodies. The only question left is, are we listening?